Welcome everyone to the O3DE 25.05 release webinar. So I am the Executive Director for the O3DE Foundation. The O3DE Foundation basically leads the efforts for all of O3DE. The O3DE Foundation determines like the vision, the plan. We attend events, we host events, all in an effort to improve the visibility of O3DE to the public, as well as I also create proposals, like contractors and things like that for the board to consider. The O3DE works with all aspects of O3DE, so project management, marketing, finance, community, the SIGs, foundation members, and the board itself. But yeah, my job is to make sure that the things run smoothly and that O3DE is basically moving onto the right path. So the purpose of this webinar, it's intended to allow the special interest groups, which are essentially the groups for the O3DE that focus on different areas of the engine. So like SIG graphics audio, SIG content, SIG core, SIG build, etc. It's allow them to talk about their work for 25.05, what all their contributions were, etc. So hopefully you will enjoy this and find it informative. So the agenda is we'll start with the simulation SIG, which is robotics and software simulation. Then we'll move to documentation, which is very important, and then graphics and audio. The graphics and audio section will be a little bit longer just because there's a lot to cover there because it was a big part of 25.05. And then we'll cover SIG content. So each person will introduce themselves when they go to present. And in general, it's the SIG chairs. So basically the people leading each of their responsible SIGs. So with that, do you want to start, Jan, for SIG simulation?
Yes, I'm ready. So I will just share my screen. Well, I cannot share the screen as long as yours is being shared, so thank you. Right, so you should be seeing my screen. My name is Jan Hanca. I'm co-chairing SIG Simulation Chair together with Adam Dabrowski. We are working for the same company, Robotec.ai, and basically we are working together to make O3DE better. So I will just give you a brief update of what happened in O3DE engine between the previous version and this version. The key part is that we added a new gem called simulation interfaces. This is the biggest change, and even though it's a separate gem, so you don't have to use it, you just need to include it to be able to use and to see the changes. So this gem is implementing the standard that was designed by Adam Dabrowski, who is leading SIG simulation in O3DE. It's a standard to unify the interfacing with simulators. It's a part of ROS2, and it's released as a ROS2 package. It's already available in ROS2 Humble, ROS2 Jazzy, ROS2 Kilted, and of course Rolling. So you don't have to do anything extra. You can just get it as any other ROS2 packages. As I mentioned, the goal is to make it unify, to have the same interface, to be able to talk with every single simulator. And it's implemented in O3DE, which is the most important for us, but it's also implemented in Isaac Sim, and it will be implemented in Gazebo very soon. I will show you, I will cover it with a live demo in a moment. Another part that is quite big that changed is that we added ROS2 inside of the ROS2 gem. We added the segmentation feature for LiDAR data. It's available with both a standard component from O3DE Extras, as well as with the backend available from our company, open source, using the GPU. Of course, this one, as well as the simulation, is really well documented. We did our best, so the documentation is available for you. I will also cover this one with a live demo in a moment. The remaining changes are a new gem for level georeferencing, the implementation for georeferencing, basically for being able to simulate the real world with the real world coordinates, like GPS coordinates. It was already in O3DE extras as a part of ROS2 gem, but we decided to split it to a separate gem so this can be used without ROS2. We also did some small changes like adding a notification bus to the spawner, re-implementing PID controller, and fixing bugs in ROS2 clock and joint manipulator. The important part is also that we removed the Python tests that were not working anyway, but were still in the code base. So this is already cleaned. For the assets, we did some work on the assets that are provided for simulation folks that would like to test something without really thinking about assets. So we provide packages with assets. We decided to clean them up and organize a bit better. So the base package with warehouse assets was updated. We removed two packages, two gems, Proteus robot and ROS robot sample. We merged both robots into one new gem called ROS2 robot samples. There are additional robots included in this gem, like Panda Franca. We also decided to remove warehouse sample gem that was basically duplicating warehouse assets. It was just a different warehouse, lower quality, so we decided to keep only one. For the templates, those were also updated. All three templates were updated, mainly simplified with removing some obsolete levels and regenerating the templates to work better. And without going into more details over here, I will show you what we did. So you should be still seeing my screen. I will start the editor and I will show you a small demo of the station. I hope everything works. As a backbone, I'm using the GPU LiDAR. So that should be a bit quicker, even though the scene is not complex at all. So it's very, very fast. So for the segmentation scene, it's a very simple scene. I have our standard shader ball and few more elements. And what's very important along the scene is that I added tags to all the entities with some objects. So you can see that the sphere has a tag called sphere. It's the same for the green one. And there are some tags also like box for both boxes. In the scene, there is also one robot. So this robot has a LiDAR sensor. I will just try to find it. It's in the covering. And yeah, that's the one. So it has a LiDAR sensor. In this case, it's slightly modified comparing to the prefab. That's why you can see the overrides. But basically, I changed the implementation to GPU LiDAR. I added some excluded entities because GPU LiDAR uses meshes rather than colliders. And I also changed the flag enable segmentation. This is a key flag to turn on the segmentation. Besides that, there is one level component which defines colors of the segmentation and which define classes of the segmentation. It's not the smoothest solution, I would say, because you need to give a tag to every single object, but it's quite efficient in terms of the implementation. So I pressed Ctrl G to start the simulation or to start a game. And now I will just open RViz2 window to show you how it looks like as LiDAR data. So this is LiDAR data, and basically I read the colors, which are different IDs for different objects. You can see the purple one for the standard shader ball. You can see the blue ones for both boxes and green ones for the sphere. Just to show you that it works correctly, I will move the robot a bit. So you can see that the robot is moving in our simulation. It is also moving in our RViz window. So I can see the objects from different angles. and the LiDAR data is segmented. All right, so that's a short demo for this part, for the segmentation. And as I mentioned, there is a documentation, so feel free to use the documentation. I will do two things. On my repository, I changed the registry setting because this is very important. I use the simulation interfaces gem, and if you use simulation interfaces gem, your O3DE behaves differently. So I will just revert the changes and rebuild assets before I continue, and I will show you how the simulation interfaces work. So the main problem with different simulators is that different simulators work differently. O3DE engine works differently because it's a game engine. So we have our editor and we have our game, and which is different than in simulation interfaces. So I had to change the behavior because I wanted to be sure that my LiDAR simulation would start. However, normally if you use simulation interfaces in your O3DE project, you would start your simulation with state stopped. And this is something you can see on the screen. So basically nothing happens here. I cannot really do anything. Just let me change the level. Yes,
for
Adam,
a bit
please
of a
continue.
context, for a bit of a context, this is the default because simulation interfaces are meant to guide automation of robot testing in a sense that where we can load levels, run scenarios, step through simulation and control the state. So starting in a stopped state is a good thing to ensure that you can populate the scene with what needs to be tested in robotics. So that's a bit different than having editor focus on human interaction, right? This is focused on API calls and automation.
So yeah, I had to restart the level in the background, and you can see that the simulation is in the state stopped. But basically, our simulation interfaces are there, and if we go through ROS2 services, we can see that we have some services like reset simulation, set entity state, set simulation state, and so on. And we can basically use our standard calls to, for example, call the service set simulation state to state 1, which is state running. And if I call it, you can see that the simulation is playing. There are different things happening in the scene, but basically you could see that the gravity took the orange ball. Of course, the calling it like that is not really straightforward. So I will just use our tool for calling simulation interfaces, and I will show you what we have in there. So simulation interfaces allow you to read all the capabilities of the simulator that are implemented. So this is with the service get simulating capabilities, and you can see that we can spawn, we can delete, we cannot use name poses, and so on. So this is our interface just instead of using the command line. We are in the state paused. We can go for state playing and we can set it. Well, it seems that I'm already playing, so I can just stop it. So I stopped it. As you can see, the simulation restarted. I can also step it by some amount of steps, like for example, 10 steps. So I can step 10 steps and the simulation will stop after some steps. You can see the orange cube falling down and stopping. We can get the entities from the scene. Like for example, we see that there is box, sphere, falling box, ground, and floating sphere. We can take our floating sphere and we can give it speed like this. We give the state, but we are still in state stopped. So if we start playing, the sphere will start moving and everything will start moving. Even things are happening, we can still move them around. So we can take the falling block and we can change the position of this one to 10 meters. And when we apply it, Sorry, I changed it in X. What I actually wanted to do is changing it in Z. So if I change it in Z, it went up again and gravity took it back down. Of course, I can pause the scene. I can set the entity first set, and I can have it in the air, and so on and so on. And what's the last feature I wanted to show you is just getting any entity I want on a scene. So all the prefabs that are available in this simulation are visible. I can take, for example, a warehouse box number 4. I can put it in position 1, 1, and name ASDF, and it was spawned over here. So basically, with this tool and with simulation interfaces, you can repeat the same procedure in Isaac Sim and hopefully in Gazebo. Right, this is what I wanted to show you. So I will let the others talk now. Thank you very much.
Thank you, Jan. That was amazing. All right, next up is Sid for graphics and audio.
Sorry, can you guys hear me?
Yep.
Okay, perfect. Are you able to see the slides? Okay, good. So my name is Siddharth Motiel. I am the graphics chair. Small background is that I worked on the renderer since its inception. I've written a lot of the components of it, and in my current capacity, I provide technical guidance around new features. I'll be going over 3 big features that went in the last release and kind of skim over the smaller features. So the one big feature that went in was a multi-GPU support. And it was contributed by the Huawei team. These are the aliases of the 4 members of the team. Big kudos to this team to take this insane feature all the way across the finishing line. The original vision for this feature was to, in the classical sense, the multi-GPU rendering essentially implies you can do stuff like alternate frame rendering, where you can render frame per GPU. You can do split frame rendering, where you can essentially take multiple GPUs and render a single frame. So you can do like a split screen or split it in more than 2 ways if you have more than 2 GPUs. Or you can do stuff like checkered frame rendering, where you can have a GPU render a subsample and then do a resolve at the end. So these are the sort of classical ways of using multi-GPU to do multi-GPU rendering. But this approach requires a SLI-based setup where you have to link the adapters together, and it's very, very constrained in its use cases. So the way we designed, or we tried to plan for the multi-GPU support, was we wanted to make sure that we built the architecture in such a way that you can have one CPU that can recode GPU commands across multiple GPUs so that it can execute workloads at different frequencies, and then you can do synchronization and composition at the end. And that will open up the use cases from just your standard classical use cases I discussed in the previous slide. So the one thing we wanted to make sure that it's API agnostic. So most of the complexity is on the RHI layer, so Vulkan, Metal, and DirectX 12. So the idea is that it handles all the synchronization, data transfer, performance related code, and the RPI layer, which sits on top of the RHI, mostly just deals with building out the render pipeline. On that note, the render pipeline has to be completely data-driven. So anybody in theory can come out, build a new pipeline, essentially say this pass goes to GPU 0, this pass goes to GPU 1, this pass goes to GPU 2, and then all the synchronization passes using just a JSON file or C++, because our pass system supports both. So the point is that you can essentially build a render pipeline that, if you want to do physics on one GPU or simulate parts of simulation on another, you can in theory build that out. We also wanted virtual GPU support, so you can have one physical GPU that can create 5 virtual GPUs, and the idea there is that you can use that for debugging purposes. we wanted all the performance-based tooling to support performance that can be tracked across all the GPUs as well as memory, so that we can fix any memory leaks or crashes related to memory bad memory accesses. We also added support for ray tracing, so you can essentially distribute ray tracing workload across different GPUs, as well as efficient synchronization. We stayed away from the older classical way of doing multi-GPU, which is the linked adapter approach. And partly because of that, we do lose some performance gains, so you can't really transfer data directly from one device to another. When I say device, I meant the GPU device. We may have to go through the host, which is the CPU. But the good thing about this approach is that it opens up the scalability options, so you can build different types of pipelines. So the original vision, this is the RC that I wrote back in 2022. So as you can imagine, this is a multi-year effort. So humongous effort, big kudos to the team. At the time when I wrote this, I'm like, nobody's going to be crazy enough to actually implement this. So this went over all the approach to sort of stay away from the older way of implementing this sort of feature and the new approach, which matched all the tenants. And last year was a massive PR that went in by the Huawei team. This PR, essentially touches every file in the RHI layer. Not every file, but most of the files. Is 800 files. And it introduced the concept of a device object, device resource, device buffer. So before this PR, we just had one object or one resource and one buffer, because Atom, the renderer, assumed that we would only have one GPU device. So everything was attached to that one device. So now we essentially have this concept of multi-device object, which tracks the same object across many devices and devices. You have concept of multi-device resource, which tracks the same resource across n devices, and the same thing with multi-device buffer. So this PR essentially upgraded the RHI to handle resources that are tracked across all the different end devices. So the point is you can introduce 5 GPUs and build a render pipeline out of that, and that should be easy to do. With this PR, we also added a sample in the Atom sample viewer. In this sample, you are essentially just to prove out, like, hey, we did all of this work. We touched every file in the RHI layer. Does it actually work? And the sample essentially kind of proved that, most of it is functional, where we render one triangle on one GPU, and then it has its own window, and it's all driven by one process on the CPU. Since last year, we have done an immense amount of improvements. So add support for ray tracing, caching. These are a bunch of PRs. I mean, there's actually more, but these are the big PRs. Efficient resource caching. You have ray tracing support. You have tooling, so the in-game profiler tracks those devices across different devices. So big kudos to all of this work that has gone in since then. And all of this work is in the latest release. So what does that mean? Like, can we see something at this point? This is sort of the new design. Like before, we just had an object, a resource, and a buffer or an image. But now with this new design, I'm not going to go into it, but this is sort of it's more complicated in the RHI layer. But the benefit is that it's completely transparent at the RPI side. On the RPI layer, which is the layer that sits on top, just says, hey, give me a pass that just runs, and these are the resources, and RHI handles all the data transfer underneath. So all of this leads up to this sort of PR. This PR was opened a couple of weeks ago. I still haven't reviewed it. I apologize. I'm just too busy with this presentation. It's not going to be in the release, but it will be getting more to development, hopefully very soon. So this PR essentially shows completing the full loop. So it actually adds alternate frame rendering support. You have a scene like this where you have a ton of meshes, which was rendering at 98 frames per second with one GPU. You add 2 GPUs, it's rendering at 150 frames per second. So this essentially shows the power of all of the work that has gone in, and big kudos to the team here. And I'm really can't wait to see what other different type of pipelines that will be coming in the coming days. The next big feature I want to go over is the shader specialization constants, and why this is a big deal for the renderer. The feature contributor was mostly Akio. Massive thanks to him. He essentially took this feature all the way to the completion across all the RHI backends. So massive thanks. So why is this important? So if you have a forward pass shader that sort of looks like this, where you have a feature that's wrapped by a Boolean, O_ feature name. So in this case, it's directional lights is the implementation, and then this is a shader, and we have this is code directly taken from our O3DE render. You have some feature and it's wrapped by an O_ feature name, which is a Boolean. So these are called shader options, these Booleans. And if your feature implementation is very optimized, how do you optimize it further? And that's what we're going to discuss. And this is where shader specialization constants come in. So why is the shader slow? So if you have a shader where you have two features wrapped by a Boolean, by a shader option Boolean. So currently, one shader results in one PSO. PSO is a pipeline state object. It is essentially a compiled version of the shader that we give to the GPU to then shade the pixels. If you have two materials, they will provide either the Boolean is true or false, and based on that, the GPU will execute and render the pixels. In the first scenario for material one, it's going to do a really it's going to be really slow because it doesn't know that the material is not using any of the features. The drivers doesn't know that the code may be used or it may not be used, so it will still allocate enough registers in case it's going to be used. So even though there's a branch in the code, it will still allocate enough registers for the ALUs that will be used by the shadow feature and the area feature. That means that downstream you can't launch as many threads. So you'll launch less threads, it will be less parallelized, and there's less throughput. So the draws associated with material one are going to be much lower than draws associated with material two. Well, material two actually needs to use these features. So in this case, it does need all the registers for it. So they'll both have the exact same cost, even though the first material doesn't even use these features. So how can we, before this release, how do we address this problem? The way we would address this is we would build shader variants. So we would build a variant per material. We essentially have scripts in the render that crawls the material files and also crawls the non-material files that has information around shader options. It builds the shader variant list. Then you have to use this list to essentially build the shader variants. And this is a very, very technical space and a very complex problem to solve for across the board for all the engines. Because when you're dealing with hundreds and maybe thousands of shader options, it becomes a combinatorial problem in terms of the amount of variants that you want to build. Because at build time, you don't really know what combination of variants. So if you have this, in this case, we need false, false, true, true, we need true, false, and false, true. So with two shader options is 4 variants, but when you have hundreds of shader options, it can really blow up. There's a whole video that I did on shader variants and how we can help people manage them. We wanted to provide a solution where nobody has to deal with shader variants at all, and it just works transparently. So the way we solve it is we do specialization at runtime. So instead of doing it at build time, we do it at runtime. So at runtime, at PSO creation time, we essentially give this information to the drivers, and then the drivers will build 2 PSOs at runtime. So all of this was happening with shader variants at build time, which is using asset processor. Now at runtime, when you load a shader, we give it the value for the shader options, and depending on if it's different, it will create a different PSO. So the drivers do a lot of the heavy lifting here, and the idea is that everything is transparent as far as you're concerned. You just load one shader, but under the hood, it will create multiple PSOs. And each draw call will be as optimal as it gets. So you never have to build a variant list. You never have to deal with variants itself. Now, there is a catch. The catch is that your compile time may increase a little bit. It varies from driver to driver. And another catch is that for console, the manufacturers don't like this approach. So they actually say it's a TRC violation. So if you're working on Xbox and PS5, you would have to go back to using shader variants. So the render supports both. So depending on your use case, you can pick the approach that you want to pick. Vulkan has explicit support. So we essentially take every shader option, add VK : constant _ ID on top. This is done by the AZSLC, our AZSLC compiler, which is our custom compiler. And then on the C++ side, we have actually explicit VK API support. So VK specialization map entry and VK specialization info. We populate these structures, give it to the driver, and the driver takes care of the rest. Same thing on the metal side. We have support for shaders get tagged with function underscore constant. And then on the runtime side, we have Objective-C API called MTL function constant values, and then everything sort of just works. DirectX 12 is a big deal. DirectX 12 actually does not have explicit support. And we essentially have to do a fair bit of trickery and hackery, and big kudos to Akio again for actually pulling this off. This is kind of technical, so I'm just going to touch the key points here. The thing is that this support is very important, because if you don't have DirectX 12 support, then you release a game and you don't have shader variants, then it's not going to work on DirectX. So we needed support across the board for all the APIs. So for DirectX 12, we essentially hacked it in. And the way we did it is we took your shader. The shader, if people don't know, the way it gets compiled to its final stage, which is Dixel, it goes to an intermediate representation stage. It's called LLVM IR. And in the intermediate representation stage, we essentially took all the shader options, converted them to a volatile constants. Then we created patchable Dixel blobs. We replaced every specialization constant with a sentinel value that we can track on the runtime side. We cached the offsets, tested Dixel blob at the build time. So this is what we're doing at the build time. So we sort of hacked in, embed a sentinel value for each specialization constant. Then on the runtime side, we replaced the sentinel value with the actual value based on the game logic. So in this case, if your mesh doesn't have shadows, or if it does have shadows, we'll replace it with a 0 or a 1. We essentially modify the bits depending on how it's encoding, how it's encoded. We reassign the shader bytes and we just give it to the driver. And in this way, we essentially hacked shader specialization support in DX12. And the great thing is, so as far as you're concerned, you run the game on any backend and it just works. And that was the end of that feature. So the next big feature I want to go over is a subpass support and why this is a big deal. Subpass support this optimization mostly applies to tiled GPUs, which are used in your mobile hardwares and VR hardware. Big kudos to the contributors here. Akio was the main driver, and then Galib and Anton also helped a fair bit. Galib and Anton are the other folks that are working on the VR side of the render. Why is this important? The reason why it's important is because the way tiled GPUs function versus non-tiled. Tiled GPUs are how your GPUs work for your mobile phones and any of your VR, AR hardware. And all the Mac is now tiled GPU. So M1, M2, M3, pretty much for the rest, for foreseeable future, Macs are all going to be tiled GPUs. The way tiled GPUs do work is very different from a non-tiled GPU, which is your standard NVIDIA AMD hardware. The way it works is for every pass, they take your scene, they grab your geometry information in frame 1. In frame 2, they break up your screen window into multiple bins, sometimes called tiles, which is where so TBDR means tile-based deferred rendering. So in the frame 2, it splits the screen up into multiple bins, and then in frame 3, it will essentially, for each bin, it will actually do the shading. Why is it done this way? Well, you also get a cool pre-Z optimization out of it for free. Why is it done this way? And the reason why it's done this way is because the memory on tile GPUs is very low because it's smaller, right? So there's very little bit of memory, and it's literally sitting right on the GPU on the SoC chipset. Whereas on bigger non-tile GPUs, you have massive amount of VRAM that sits close to the GPU, and there's usually a very high-speed bus that connects the GPU to the VRAM, and that bus is usually really fast. So because you have a very small amount of memory, how do we make sure that we are able to shade in an efficient manner? And this is the solution for that. So what this does is you shade per bin. It's done really fast because the memory is sitting on the GPU, so all the loads and the stores are essentially free. The only thing that takes time is to take this bin from the GPU to the CPU system memory. So you have to do it one bin at a time, and then every time you're done, you have to transfer this memory from the GPU to the CPU, and that's where the cost comes in. So can we optimize for that? So if you're given a render pipeline that sort of looks like this, you have 3 shadow passes, forward pass, skybox pass, display mapper, and a UI. So these are very simple pipeline. Can we optimize this to be way more efficient on a tile GPU? Yes, we can. You can essentially, in this case, if you leave the 3 shadow passes alone, you can essentially merge the forward pass and the skybox pass such that When it does the binning for the forward pass, it essentially does the skybox right after. So for each bin, it will do the forward pass shading, it will do the skybox pass shading, and then it will move the memory from the GPU to the system memory, and then it will do the next bin and the next bin. And the same thing applies to the display mapper and the UI. And what we have done is we've eliminated the bandwidth movement for the skybox and the UI. So for skybox and the UI, you don't have to move the memory out of the GPU back to the system memory because it's going to do it exactly at the same time. So when you call execute, it will shade forward plus related workload and then the skybox. Now, not every pass is mergeable. There's some criteria that needs to match. So if any downstream passes have a filter where you're sampling neighboring pixels, then you cannot merge them. Anytime you have to change the render target configuration, you cannot merge. So there's some criteria that needs to be met. If the criteria is met, you can merge. And if you merge, you save all the cost associated with bandwidth movement for downstream passes. So how do we add support for that? We extended the RPI pass system, where if you can now tag a pass as mergeable, and then RPI under the hood will automatically try to figure out the criteria associated with it, and if it can merge, it will merge. So in this case, if all the children passes, so pass E, I, C, G, and H, if we can merge it will all become one big pass group. But let's imagine if, let's say, render pass C is a compute pass, whereas E and I is a raster pass. So then what it will do, it will automatically say E and I is merged into one pass group, C is one pass group, and G and H is another pass group. So it'll be three different pass groups, but it will all handles dynamically by the RPI system. On the RHI, we obviously expanded the RHI significantly to add this support. This is a huge amount of effort here. We essentially have to build the vendor passes in a different manner. So Vulkan has explicit API support. It literally has, the subpass concept is a Vulkan lingo. So it has explicit support. So we have VK subpass description, VK subpass dependency. So it was kind of easier to do on the Vulkan side. I won't call it easier because Vulkan is a very technical API, but at least it supported it very explicitly. Metal doesn't really have explicit support, so we had to do a little bit of hackery here. The big problem with Metal is how do you update the shader? All the shaders have hard-coded indexes on where the output of the shader needs to go. So we need, and this output index, so in this case, we're writing a color to SV target 0, which is render target 0. This can be changed if you merge a pass, but we need to be able to provide that information from runtime at runtime. And the way we did that is we essentially modified the SV target 0 to a function constant, and then we can provide the value for the function constant at runtime. So that way, if you merge two passes and the output of those passes change, we can update that. And then Metal kind of takes care of the rest. So we got a little bit lucky there, and we did a little bit of hackery, and then we were able to get subpass support for Metal as well. We don't really care about DirectX 12 because DirectX 12 phones was a thing, but it's not really a thing. Maybe HoloLens can be a thing in future, and if HoloLens becomes a thing, because they're probably using tile GPUs, then we will add DirectX 12 support. Those are the three big features. These are the very minor features: vertex colors, geometry view, pass system improvements, ray tracing improvements, various performance optimizations, various crash fixes, deadlock fixes. Please take a look at the release notes. Please join the Discord if you have any questions. Big kudos to all the contributors who've helped and who've been in the Discord providing guidance. I'm also there available, so reach out to me if you have any questions. And yeah, that's the end of my presentation. Thank you. I'm going to stop sharing.
Thank you, Sid. Awesome work. A lot of optimization, which is really important with graphics. So next up is Luis for Say Content.
All right, thanks. Thanks, Joe. All right, hi everybody. I'm Luis Sempe. I am the chair for C Content. C Content covers a large number of the tools that O3D uses to create content, so scripting, track view, but it also covers some of the systems themselves, like the asset browser and the tools that it uses, like the document property editor. So in this release, the goal was to work a lot on the stability, performance, and easing a lot of the pain points that have been in the engine for a while now. So a lot of long-standing bugs. So let's get into it. For script canvas, starting there. First of all, we fixed a crash that whenever you close the editor, it would crash, and that's just terrible. So that was an easy fix. Same, there was a somewhat rare crash when you run the game associated to script canvas that's been fixed. Some fixes that just add stability, like trying to open an invalid file. Maybe got corrupted by some operation. Maybe you try to open a text file or something. So that no longer crashes. It will tell you that that file is invalid. One of them that's a big one that caused a lot of confusion was fixing the default file path when saving graphs. Often this would take you to a place outside of the project structure, and then you could save your file, but then it wouldn't show up in the project, so asset processor wouldn't pick it up, and you'd be wondering, why is my script not working? Why can't I use this? So now this has been fixed to always create a file, a script canvas file within the project structure. So that should alleviate a lot of that weirdness and confusion that people experienced. Some other work that's kind of in process is, first of all, we restored the live debugging window, but the live debugging on script canvas is still not quite functional, but there is work in progress to improve that. So in a future release, we'll have that feature back. A few fixes regarding variables in script canvas. There were things that if you rename them, all the references in the other nodes would not get updated. And the way variables were being used when you assign them to a slot, it was like a local variable in a function within the generated Lua, which made it so that you wouldn't keep the value across the section of that script. So fixes like that. Then moving on to Lua, not as many fixes here, but we did fix there were script properties initialization issues in prefabs, which led them to get, I believe they got stale basically. And so that's no longer the case. When prefabs initialize, all the properties get initialized to the proper values. Then on the Lua editor side, there were some connectivity issues to the O3DE editor. So the Lua editor works by connecting through a network socket to O3DE, and that allows to do the debugging and working, setting breakpoints and evaluating your scripts that way. So by fixing those connectivity issues and the remote tools, we're producing a lot of spam as a result. Those fixes make it a lot more stable to use the Lua editor. Next up, TrackView has received a large number of improvements. A lot of them are very important quality of life improvements. This is a tool that is quite dated. We hadn't had any work on it for a long time, but we have a bunch of contributors just making it a really, really good tool. So some of the things that went in there is just making sure that we create the proper sequence agents components, making it a smooth workflow when we're adding entities to and from the sequence, improving the undo redo operations. When you switch to running the game, it will apply all the changes you have made. Before it wouldn't apply them, so it would run the track view with the previous values, so it didn't represent what you were actually working towards. And fixing rotation and color keys, which were incorrectly handled, leading to just bad results. More fixes here. There were a lot. UI glitches in the track view dialog. Like I mentioned, this is a pretty dated tool that needed some improvement on its UI as well as on its operations. I think I have a duplicated entry there. We'll skip over that. Oh wait, is the same slide? There you go. Also modernizing the code behind the scenes, and applying some of the more O3 centric strategies for avoiding crashes, error reporting, and just improving the overall readability and maintainability of the TrackView code. A lot of great strides in that side. Then on the document property editor, this is the technology that drives when you modify properties on an entity, when you are inspecting all the values in an entity. Whenever you made a change, it was requesting the size for all the widgets in the property grid, basically, resulting in a huge slowdown if you had a large number of entities selected. So now this has been optimized to not do that. which did improve the performance by quite a lot. I don't remember the actual metric. Same fixing more on the redo issues, and also with prefabs, some stability fixed crashes when editing overrides on prefab instance. And that covers it for content. Like you see, it's mostly a pass on stability, improving the code quality, improving performance, and just fixing a lot of issues that could lead to confusion or just bad situations that fortunately now we're less prone to get into. I think that's all for me. Thank you.
So now we will move to documentation.
All right. So yeah. So I'm Shauna. I'm the chair of SIG documentation for those that don't know me. And I've been working lately with JT. He's been recently promoted to maintainer. And so yeah, we've been working on a bunch of stuff lately. And I've been working primarily on steering stuff, infrastructure, and just general maintenance improvement. JT's been working a lot more on community outreach, content architecture, onboarding. And then we've also had Jan and Guillaume doing a lot of content stuff. So special thanks to you guys for all that hard work that you've been doing. We're not as flashy as what 6Sim is, sorry about that, but you know. We've been doing a lot of kind of maintenance work and stuff like that. So big thing, updated content lately. Like I said, Jan and the simulation guys have been doing a lot of content updates. They did a profile tutorial. That's a big thing. That was a whole big tutorial. It was great. And been adding samples and got a bunch of little things, you know, here and there, typos, stuff like that. We've been also doing, like I said, a lot of infrastructure stuff, a lot of foundational work for the how do I put this? Foundational work to facilitate the things that we've been the more showy stuff and the a lot of the features that we've been wanting to add later. One of those big foundational things was pulling out the API docs from the main repository, so we don't have these big, massive, very difficult to work with pull requests whenever we do. Sorry. Whenever we do big updates now, and it's automated.
Yay.
I'm so happy about that. Yay!
Yay!
All you gotta do is push a button. So yeah, now all you gotta do is push a button and it generates it all and opens up a pull request, and then you just make sure that it, you know, nothing crashed and burned, and stick it in, and then do another little pull request on the main repository, and all of a sudden we have new API docs. It's great. I love it. That is a step into potentially automating that even further, so that it will do that, you know, possibly automatically. It can do the, you know, eventually we'll be able to do the whole thing automatically and then just say, hey, give us the new version, and it's great. Another one of the other major updates is we also pulled out the theme from that. The doc site is a Hugo site under the hood, and so in relatively recent updates, Hugo has created a concept of modules, which is what is allowing us to pull out both the theme and the API docs and putting them in their own repositories. This allows us to do these larger updates, larger theme updates that we're going to want to do. and allows the main repository to be more focused on content, which we're hoping will help content contributors to jump in a little bit easier and not be quite as intimidated with all the other extra stuff that's in it. And allows us to have, content updates in the one and more theme specific updates, and have those just separated just in general, because I am a programmer and I like separation of concerns. So what's next for us is going to be a lot more of the showy stuff, so that we'll actually have, a screen share possibly next time, besides just slides for you guys. But that'll hopefully allow us to do format flexibility, so we can do, we've had requests a couple times for like PDFs or printable versions. We can also have more raw stuff for, I've seen a few things of like wanting to have a way to take context and put it into, an LLM or something like that, make it easier for machines to read and stuff like that. Dark themes and following the system theme, so it's not just the white background for those of us that prefer the darker colors. Improved search. We've had some feedback about the search not being great. So we're gonna see about doing that as well. And then also we have the content architecture revamp. This is the kind of one of the bigger things that allows us to that these changes will allow us to do, because that we can focus on them a lot more. JT's been working on the foundational work for this stuff lately, so we've been talking about different user types, user archetypes. So things like the new person who doesn't do a lot of programming, or the new person who is a programmer and wants to dive into, say, the Lua stuff, or the engine developer, and have those as separate things to make it a lot easier for them to dive in and actually have the relevant information in hand more quickly. He's also been working on onboarding stuff and streamlining the onboarding process, so that way our goal is to get somebody up and running with a functional level. What's our ultimate goal, JT? What, an hour ultimately?
Pretty quick.
Yeah.
Low to no barrier, low hassle.
Yeah. I think our first step is like within a day, and
Yeah.
then we want to narrow that down to like an hour or two, hopefully, to have something basic.
Yeah, the first time you sit down, you'll be able to actually get it done without having too much to mess with, and then you can start working right away.
So yeah, and then also scaling. We're working out things like style guides and all this foundational stuff to allow us to scale out, so it's not just the handful of us, and then we can get more people in and they can feel better jumping in. So right now we are a small team. Like I said, it's me, JT, and a couple other people who have been in this and doing occasional contributions and somewhat more regular contributions and stuff like that. We actively want to grow it, so if you're interested at all in any of the stuff that we've been doing, or the stuff that that we're in the process of doing, by all means come join us. We'd love to have you. We'd love to have, even if you're not sure like how to do stuff, we'd love to help you out. The more hands we start getting on this stuff, the better. And with all of these, we'll be able to do more tutorials. We're looking also to do formalized or more formalish sprints of batched updates. So things like the proofreading and like fixing broken links and stuff like that. We'll want to like group up and dive in and knock out a whole bunch of those. and we want to get more quality of life updates. Like I said, style guide formalization, and even some more automation. I've got other ideas for those as well. So, but all of those we'd love to have help with.
Yep.
Did I leave anything out, JT?
No, join us in our
No,
Discord channel.
yeah.
Our Discord channel's pretty active. Hop on in, jump in on all the fun.
Yep. So yeah, come talk to us. And we look forward to being able to show you some of the more flashy stuff in the future.
Thank you, Shauna. The work that you all have been doing to make it easier for people to contribute to documentation has been amazing. It has taken processes that used to take days, and now it's less than an hour, especially when we're doing releases. So yeah, thank you very much for that.
Yes.
Okay, so please join us on our socials. Well, one, thank you all the presenters for presenting for your particular areas. This is some awesome work for O3DE for the 2505. I think you will notice a theme in many of the areas, which is making life easier for the users of O3DE, as well as improving stability across the board. That focus will continue in our next release, which will be 25.10.0. And that's something, we are never going to drop, is that focus on stability and quality of life. So with that, you can join us on GitHub, check out our YouTube videos. There's a lot of tutorials coming up, and there's some new ones that are currently in progress. Discord, which is our primary mechanism for supporting people who are using O3DE. All of the SIG chairs hang out there. A lot of our contributors hang out there, and and our response times are pretty good. So if you have a question, go ahead and ask. There are no stupid questions. The community's very nice about especially helping new people along who are new to O3DE. And then, you can also check out our LinkedIn page. I tend to post there, and our marketing group tends to post there as well. Please subscribe to our newsletter. You can use this QR code to do so. If you need a link, feel free to message me on Discord, and I can provide that as well. And then as a note, I am planning to host an AMA in September. So, all the questions you may have, etc., you can save those for then. If you do not want to save them, feel free to reach out to me on Discord, and I'm happy to answer any questions you may have. I am on there as Joe Bryant. But that is everything I have. Thank you, everyone. And thank you, attendees, for listening to us for an hour.